Hey guys, so in this video I'm going to be talking about what is voltage, current, and resistance. And if you're not sure exactly what electricity is and what the flow of electricity is, I'd recommend watching my first video on atomic theory. I'll post a link for it. But this one is about voltage, current, resistance. And here I have a basic circuit, and again I'm using electron theory of negative to positive to kind of help show how to understand what that voltage, current, and resistance is. So voltage is that driving force. It's the force that pulls and pushes the electrons throughout the circuit. So as I stated in my last video, that electricity is a flow of electrons, and electrons are a negative charge. That's why they flow negative to positive. Because when the battery is charged and all these electrons are on the negative side of the circuit, the positive side of the circuit, once you complete it, is going to magnetically attract those electrons. That's pulling them, magnetically attract them. So that's what that voltage is. It's the positive side of the circuit magnetically pulling the electrons throughout the circuit. While at the same time, likes repel, so the negative side of the circuit is also repelling those negative charged electrons. So that's what voltage is. It's that force, it's that driving force that makes the electrons move by pulling them and pushing them throughout the circuit. And it's measured in volts. Resistance is basically anything that stops and reduces the electricity from flowing. It's measured in ohms. It's kind of like when you compare all this stuff, one way a lot of people like to compare electricity is like water flowing through a pipe. So if I have water flowing through a pipe, that pump that's pushing that water throughout the pipe is what the voltage is. It's that driving force. If I put a kink in the hose and stop it from flowing or just reduce it a little bit, that's resistance. And same thing in an electrical circuit. Any type of insulator that stops it from flowing, or even just a load itself, that is resistance. And like I said, it's measured in ohms. It's anything that stops it from flowing. Now, current is the flow of electricity. I like to kind of call it, it's like the outcome of it. So you can manage voltage and resistance. You can amp up your voltage, and that'll increase your current, or you can reduce it, and that'll decrease your current. Resistance is the opposite because it stops it. The more resistance you have, the less current you'll get, and the less resistance you get, the more current you get. So it's kind of like in math. When you're solving for x, you're basically putting in once you find what x is and you plug that into the equation, you get the answer. That answer is actually your y value. It's basically on a graph. So if you have a point over 5 up 2, the 5 is the x-axis. You plug that into the equation and you get out 2 because it was over 5 up 2, and 2 is your y value. That's basically what current is. That's why I like to call it the outcome. It's basically the flow of electricity, and it's measured in amperage, and it's dependent on voltage and resistance. So that water pipe kind of comparison, the amount of water that's flowing, that's your current flow. It's basically the, like I said, it's the flow of the electricity, and it's dependent on your voltage and resistance. You can manage your voltage and you can manage your resistance, but you can't just change your current. Your current is dependent on your voltage and resistance. And again, like I said, it's measured in amps. And that's basically it in this video. In my next one, I'm going to be showing how to use Ohm's law, how to calculate voltage, current, resistance when you're given two of them, and you have to find out the third. Thanks for watching, and please subscribe.